I'm the last person, so I'll keep it very brief. As you hear from my funny accent, I'm from Europe originally, and this is sort of going to tell you sort of how to make an international scientist out of you guys. I work also at the National Research Council, Institute for Field Set Innovation. It's just there were 2 horses down the road, and if you ever want to visit that, we also have tours and stuff that we guide you through the labs. It's pretty interesting. Also work with the Let's Talk Science Partnership Program, where we do outreach into classrooms, and if you go to universities, it's a national organization. I'll talk a bit more about it later. We're always looking for new volunteers, so once you're at universities, you're welcome to join. I'm also doing my PhD at the site, so I'm a bit earlier in my career path than the other speakers, and I do that together with materials engineering at UBC. Let's show you a little map. Turn over well. Just can't see any map there. Science. So this is a map of Europe. Obviously, that's where I'm from originally, but the number 1 is Frankfurt region. And I started my undergrad career there at the University of Darmstadt, a small city. And the first year was really, for me, the most disastrous. I didn't really understand what was going on. Math and physics were sort of way above my head and didn't have a clearly defined path or aim. So what I did after the first year, I did sort of what you might call a summer term work at a federal government lab called the Max Planck Institute for Polymer Research, and worked on proteins. And that's, again, in a small city quite close to here. So maybe you've heard of Opals, that's the cars where they make it. They also have that research lab there. And that really got me interested in science, technology, and research. And so that got me focused. I got back to university and really started to just press through my undergrad to go into grad school and do research. Coincidentally, the European Union is very good in exchange programs. So you can do an exchange program for 1 semester or 1 year into any of the countries. There's a couple of opportunities depending on the university you're in. And I went to Bath University to finish off my undergrad term there. And when I worked in the Max Planck Institute, there was a postdoc who was now a professor at Bath University. So it really linked together. I met him and did a research project for him on the side. So that was it was coincidental, but you keep building your own network while you are at institutes and universities, and just keep in contact with the people that you are working with. You never know when you meet them again. So I ended up doing something with him there, and even after I left, even while I was at Canada, I was still working on that project on the side, so to get some publication and patents out of that. Anyways, I couldn't stay there. They closed my department, so I was the last final year they had. I had to leave the country. I think they didn't want me. I went to Sweden, Gothenburg University, did my master's there, and then once I had my master's, I went to Denmark, which is this little thing there, Chisholm, in a small town called Roskilde, at a, again, federal government lab called NRC-IFCI National Labs. That was pretty interesting. I got involved in fuel cell technology, and that sort of got me interested in this whole alternative energy thing. I met somebody at a conference from Canada, hooked up with him, and stayed in contact, and that sort of ended up bringing me to this place of the world. Number 6. Where's number 7? I don't know yet. Once I'm done, maybe Singapore? We'll see. You'll find out. I've been here since 2005 and been working on my PhD. As I said, materials engineering as a partnership between UBC Engineering and the NRC. So why do we talk about fuel cell technology? So you get a little breakdown of why we go into alternative energies. And I'm just going to hand you this thing around. If you look at this, this is one of the alternative energies that we have. And there's a little bit of methanol in here, and you can just hand it around. You switch it on, and there's a wheel turning. So it's not too flashy. But you will see you directly convert the energy stored in the methanol there into water and energy. So that's an alternative energy source that we have. And this is one of the many sources that we will have. Fuel cells can use any type of fuel, especially my type of fuel cells, called solid fuel cells. They operate at 1,000 degrees, and they can use wood, coal, gas, gasoline, diesel, methanol, ethanol, hydrogen sulfide, hydrogen, any kind of fuel that we have available today can be used directly in those fuel cells with much higher efficiencies than if you would burn them directly in an internal combustion engine. So you can use all the fuels we have, but with a much higher efficiency. You can drive twice as far with the same amount of CO2 produced, for example. So this is the big advantage of fuel cell technologies. Without going too much into the details, NRC-IFCI, the one that I'm heading around here, and the other one operating at 1,000 degrees. Unfortunately, I can't hand it around. It would be sort of bulky and very warm. But the big advantage of this high temperature thing, there's no water coming out of it. 1,000 degrees, you don't have any water, but it is the most efficient type of fuel cell that we have. And there's big reactors being done. So almost, well, I wouldn't say like certain, but almost like a big nuclear power plant. That's the same scale. It is that sort of fuel cell type. So this is just for mobile applications, and we are working on the big type of fuel cells. The research that is going on there, and I'm just going to mention these three things. What do we have to address? Why don't we have fuel cells at the moment? They're too expensive, they're not reliable enough, and they don't last long enough. If you have a great motor in the car and you have to replace it every 2 months, that's not going to work. So we're making that possible. And a couple of projects that we have at EFCI NRC, one of them is a plasma spraying method. That's pretty cool. If you ever want to come along, it's a gun that fires a flame that's 24,000 degrees warm. And with that, we produce our fuel cells in 5 minutes. It's very nice. It stands at Ample in a facility at UBC. So if you ever visit us, we can show you how that thing works. There's other things that make the cost really high. Platinum, for example, that has to be used in those fuel cells. There's a little bit of platinum on that one. It's too expensive. We have to replace it with other metals. And then we sort of try to invent new methods of making the materials last longer. This is how the facility looks like when we do that. Just south of here. And as I mentioned, you can visit us at any time. So just going a little bit into the outreach that we do in combination with UBC and the National Research Council. The Let's Science Partnership Program is a national non-profit organization. And we reach typically about 200,000 kids throughout the country. And at UBC alone, we're the biggest site. Every Canadian university has a little chapter of Let's Talk Science, and they go into different into schools, into public events, spreading the word on science. And both, if you want to have a scientist in your school, or if you want to become one of the volunteers once they are at university, check out the Let's Talk Science Partnership Program. It's at every university. How does it look like? For example, we go to public events, talk about little fuel cells there. You see a bit more complex setup of what I'm handing around there. Talk about bicycles. That, by the way, is the box where we have the 24,000 degrees flame in there. And we do solar farms for the younger generation. All in all, sort of to get more knowledge about the science and technology out into the world. And we also develop our volunteers. So if we have students working for us, we sort of get them to improve and to raise their profile on campus. And we just recently found out that funding organizations are specifically looking for you to do volunteer work, especially in Canada and especially with LTS. So if you have that on your CV, it's definitely advantageous. So if you're interested, at UBC, that's ubclts.com, or it's letstalkscience.ca. I've got a handout at the end where you can see that a bit more. Just to wrap it up, 3 things to talk about. Well, do part3 studies and work in different countries. If you manage to do that, and I think there's at the International House at UBC, I don't know, at other universities, but it's probably pretty common at all universities that you can have exchange programs throughout the world, really. To go 1 year to work in Paraguay, or do your studies in India. That's certainly possible, and you should definitely do it. It just broadens your horizon so much. You get into contact with new people, you get to live in other countries. It's really it's a great opportunity. And keep your eyes open for opportunities. As mentioned before, you can get to go to conferences. That's where you meet the people and talk to them. Like there's this big speaker who, whatever. They're normal people too. They've been working in the field maybe 60 years longer than you, but talk to them. They might know somebody if they can't directly give you work. And then that's how you find work in other institutes in other countries. Engage in research and development. I totally love it. You will once you are for undergrad, I'm pretty sure. It is just amazing. You do things that nobody else had essentially has done before, and then you discover that and tell the world about it. And then while you do that, you spread the word on what you do. You volunteer in your communities, and you get what you do not only to your peers, but you bring it to the rest of the community and talk about it on a more basic level.